Here is something I want you to really sit with for a second. Your doctor has probably told you to eat less sugar, maybe cut back on soda, watch the sweets, try to be a little healthier. That's it. That's the whole conversation. But the published science, studies sitting in peer-reviewed journals that your doctor almost certainly has read, tells a completely different story. A story about how sugar rewires your brain, silently inflames your body, accelerates aging at a cellular level, and creates a dependency cycle that is not a matter of willpower. And the reason you haven't heard any of this in a doctor's office, that's exactly what this video is about. Hey, welcome back. If this is your first time here, I make videos about the science of how the things we eat every day are actually affecting our bodies. Not the headline version, not the watered-down version, the real version with the studies and the mechanisms behind it. Today, I want to talk about sugar. And I know you've heard about sugar before. I know there have been 1,000 videos and articles and documentaries, and none of it has probably changed that much for you. So let me tell you right now, I'm not here to tell you sugar is bad and you should stop eating it. You know that. What I want to do today is show you the specific science that almost never makes it into the conversations most people are having about their health. The stuff that lives in the research but somehow never reaches the patient in the doctor's office. This is not about shaming anyone for what they eat. It's about giving you information you actually deserve to have, so you can make real decisions about your own body. Let's get into it. What your doctor is actually working with. Let's start here, because I think it's important to understand why this gap exists, and to be fair about it. Your doctor is not hiding things from you. Your doctor is working inside a system that has a very specific framework for how health conversations happen. You come in, they have maybe 12 to 15 minutes with you, they check your numbers, they address your symptoms, and they give you the most broadly applicable, consensus-approved advice they can in the time they have. Eat less sugar fits in a 15-minute appointment. A full explanation of what sugar does to your mitochondrial function does not. There is also the issue of medical education. The average doctor receives somewhere between 2 and 4 hours of formal nutrition education across their entire training, not per year, total. So even the best, most well-meaning doctors are working with a nutrition framework that was largely set decades ago and has not kept pace with what the research is actually showing us now. This is not a conspiracy, it is a structural problem. And the person who pays the price for that gap is you. So what is the science actually saying? Let's go through it. Sugar and your brain. The mechanism. Nobody explains. When you eat sugar, your blood glucose rises and your pancreas releases insulin to bring it back down. You know that part. What most people don't know is what is happening in your brain at the same time. Sugar triggers a release of dopamine in the nucleus accumbens, the same reward center that responds to addictive substances. And here is the critical detail. It is not the sugar itself that creates the problem. It is the pattern. Every time you eat something sweet, your brain logs a reward, and it logs the context around that reward, the time of day, the emotional state you were in, the activity you were doing. Over time, those contexts become triggers. Your brain starts anticipating the dopamine hit before you even taste anything, which is why you can feel a craving just from seeing a certain food, or being in a certain place, or feeling a certain way. The craving is not about hunger. It is a learned neurological response that has been reinforced hundreds or thousands of times. A 2013 study published in the American Journal of Clinical Nutrition showed that high glycemic foods that spike blood sugar quickly, activated the nucleus accumbens more intensely than low glycemic foods. The same region, the same mechanism. And what that means is that the cycle of craving, consuming, and craving again is not a character flaw. It is a trained response pattern that is running in the background of your brain, whether you are consciously aware of it or not. Your doctor will tell you to eat less sugar. The science tells you that you are working against a conditioned neurological loop, and understanding that loop is the only way to actually change it. The inflammation. Nobody is talking about here is the second thing the science shows that almost never comes up in a standard health conversation. Sugar is one of the most potent drivers of chronic inflammation in the modern diet. And chronic inflammation is not a condition. It is the underlying mechanism behind most of the diseases that are killing people at the highest rates right now. Heart disease, type 2 diabetes, certain cancers, Alzheimer's disease. The research increasingly points to chronic systemic inflammation as the shared root. When you consume excess sugar, particularly fructose, your liver gets involved. Fructose is metabolized almost entirely in the liver, and when it arrives in quantities that exceed what the liver can process efficiently, it gets converted to fat. This process, called de novo lipogenesis, produces inflammatory byproducts. It also contributes to a condition called non-alcoholic fatty liver disease, which is now estimated to affect somewhere between 25 and 30% of adults globally and is almost entirely driven by diet, not alcohol. Diet. There is also the effect on gut bacteria. Your gut microbiome, the roughly 38 trillion bacteria living in your intestines, is deeply sensitive to what you eat. High-sugar diets have been shown to promote the growth of pro-inflammatory bacterial strains while suppressing the beneficial ones. And when the balance of your gut bacteria shifts, the permeability of your gut lining can increase, a condition sometimes called leaky gut, which allows bacterial compounds to enter your bloodstream and trigger a systemic inflammatory response that affects your entire body, including your brain. You will almost never hear this sequence of events explained in a 15-minute appointment, but it is in the literature. It has been replicated, and it is directly relevant to how you feel every single day. Sugar and aging, the glycation, nobody mentions. This one I find particularly fascinating, and it is almost entirely absent from mainstream health conversations. There is a process in your body called glycation. It happens when sugar molecules attach to proteins and fats and create abnormal structures called advanced glycation end products, AGEs. That is not a coincidence of naming. These compounds accelerate the aging process at a cellular level. Glycation affects collagen and elastin, the proteins that keep your skin firm and elastic. It affects the proteins in your arteries, making them stiffer and less flexible, which is a direct contributor to cardiovascular disease. It affects the proteins in your eyes, contributing to the development of cataracts. It has been linked to the protein tangles found in the brains of Alzheimer's patients. And every time your blood sugar spikes, you are creating more of these damaged structures. The amount of glycation happening in your body at any given time is actually measurable. It is part of what the HbA1c test is reading when your doctor checks your blood sugar control. But most people only hear about this in the context of diabetes management. The reality is that glycation is happening on a spectrum in everyone, and the daily dietary choices driving that spectrum are worth understanding long before you are anywhere near a diabetes diagnosis. The insulin resistance, nobody warned you, was coming. Let's talk about insulin resistance, because this is perhaps the most important piece of the puzzle and the one that gets the least airtime until it is already a serious problem. Insulin resistance is a condition where your cells stop responding normally to insulin. Your pancreas compensates by producing more insulin. Your cells respond even less. The cycle continues, insulin levels creep higher and higher, and eventually the system starts breaking down. Here is what insulin resistance feels like before it shows up on any test. Fatigue after meals, difficulty concentrating in the afternoon, persistent hunger even after eating, weight that tends to accumulate around the midsection and resists coming off, and mood instability that seems to follow a pattern related to when you last ate. Sound familiar? These are not just general lifestyle complaints. They are often the early symptoms of a metabolic system under sustained stress. The research shows that repeated blood sugar spikes, which happen every time you eat high sugar or high glycemic foods, are one of the primary drivers of insulin resistance over time. And this process begins well before it would ever show up as a problem on a standard blood panel. By the time your fasting glucose is elevated enough to flag concern, insulin resistance has often been building quietly for years. Your doctor will catch it eventually. The science tells you that the window to act most effectively is much earlier, and that the dietary patterns driving it are ones most people are engaging in every single day without any awareness that a clock is ticking. What the research actually recommends. Now here is where I want to be careful, because I am not a doctor and I am not here to prescribe anything to anyone. What I can do is tell you what the research points toward and let you take that into your own conversations with your own healthcare providers. The studies consistently point to a few key principles. Reducing added sugars and high fructose corn syrup shows measurable improvements in inflammatory markers within weeks, not months. Replacing high glycemic foods with lower glycemic alternatives, whole grains instead of refined, whole fruit instead of juice, legumes, vegetables, quality proteins and fats, significantly blunts the blood sugar spikes that drive the cycles we have been talking about. And perhaps most importantly, addressing the behavioral and neurological dimension of sugar consumption, understanding your triggers, building new patterns, not relying on willpower alone, is what the research shows actually produces lasting change rather than cycles of restriction and relapse. None of this requires perfection. None of it requires you to never eat something sweet again. What it requires is understanding what is actually happening in your body, because you cannot make informed decisions about something you have never been properly informed about. Why this conversation isn't happening. I want to come back to the original question before we wrap up, because I think it deserves a direct answer. Why is this conversation not happening in most doctors' offices? Part of it is time, as we discussed. Part of it is training. But there is another dimension that is worth naming directly. The medical system is primarily structured to treat disease, not to prevent it at a mechanistic level. The conversation about insulin resistance happens loudly when you have type 2 diabetes. The conversation about inflammation happens urgently when you have cardiovascular disease. But the years-long window before those diagnoses, the window where understanding the science could actually change the trajectory, that window often passes in silence. You have a right to this information, not because it will fix everything, not because diet is the answer to every health problem, but because understanding what is happening in your own body in real biological terms is a form of power that nobody can take away from you once you have it. And that is why I make these videos. All right, let's land the plane here. If you take one thing from this video, let it be this. The reason it has been hard to change your relationship with sugar is not because you lack discipline. It is because nobody has ever explained the actual mechanisms to you. The dopamine loop, the inflammation cascade, the glycation process, the insulin resistance timeline. These are not scary things. They are understandable things. And understanding them is the first step toward actually changing them. Here is what I want you to do right now. Leave a comment below with the one thing from this video that surprised you the most. Was it the brain science, the inflammation connection, the glycation piece? Tell me. I read every comment, and your responses genuinely shape what I make next. If you found this useful, please share it with someone who would benefit from hearing it. Not to scare them, not to lecture them, just to give them the information they deserve to have. A lot of people are struggling with their energy, their weight, their mood, and they have never been told the biological story behind what they are experiencing. This video might be that story for someone you know, and if you want more content like this, real science, explained clearly, with no agenda other than giving you useful information, subscribe and hit the bell. I post every week and every video is built on the same principle. You deserve to know what is actually going on inside your own body. I'll see you in the next one.